Okay, in the second part of this lesson, we'll be looking at the types and locations of graphics in different research articles. Now, current data are usually presented in graphics because graphics make it much easier to see patterns in the data. And as we've said, patterns are very important in data. Data also need to be discussed in the text, however. At a minimum, the writer needs to mention each of the graphics, pointing to it. But in IMRD in particular, it's common to talk about what you should look at in those graphics. In IPTC, there may be many specific types of graphics that are common in the field, and it's assumed that readers will be able to interpret just by looking at that graphic. Now again, it's important to remember that graphics is not the same as graph. Graphics includes both tables and figures. Tables includes numerical tables. Those are the most common in science and engineering. But you may also have non-numerical tables. Things like parameters, conditions, that talk about the settings that went into some research, where you're not comparing sets of numbers, but you're just looking at where those parameters were set. And then in figures, you have both graphs and illustrations. A lot of writing texts talk about figures just as graphs, and that could include line graphs, bar graphs, and many other kinds. But in engineering, illustrations are also very important. You have photographs, and particularly many different kinds of diagrams, many different kinds of schematics, which are very important in engineering. Okay, now we'll look at the graphics in our chemical engineering article.
Okay, so now we can first look at here. It's a special part called graphical abstract. Some of the journal, they require that we have to put this one. But I think it's a good thing that we can go through the whole topic by this. And here we see the introduction, no graphics and no figures. Also the method division also don't have because they are calculations.
Right.
So almost all of the figure are in the result and discussion division because we can see that they started from figure 1.
Okay. So even though these occur before you get to that designation, you look for the thing that says figure 1 in terms of determining what division to call those.
Yes, because some of the journal that they would like to put the figure in the last part of the page.
Right.
They doesn't like to put at the beginning. So sometimes they will put before the article that they mentioned.
Right.
So we can see that here we can find. Yes. So the graphics here is illustration is obviously. And now this is the graphs that we can also see it really clear. And here also the graphs. And now here that is figure 6. That there's half graphs and half illustration.
Right.
So the illustration that support these graphs.
Right. So this is one of the difficulties in counting, because if you're counting just the number of numbered figures, it may not include the fact that this one figure has 2 graphs and 2 illustrations. But on the other hand, in terms of the number of places it's mentioned in the text, it's important to know how many numbered figures there are as well. So in the table, we're going to show both the number of actual graphs and illustrations, as well as the count of figures, because both are important for different purposes.
Yes, because using the illustration to support the graph, it kind of being more common in chemical engineering.
That's true.
So we have to count it like half and half.
Right.
Yes.
Yeah.
And now we can see the conclusion that there will be no graphs or tables. That is also really common here.
Right. It's common across all fields of engineering.
Yes.
Now we'll look for the graphics in our mechanical engineering article.
Okay, so let's look at the introductions. As you can see, this one, actually we have not any graphic in this one, but it show in the section 2, because in section 1 they will describe about the figure 1 here.
Okay.
Figure 1 is describe about the schematics, not the graph. Even they show the XY.
Right, it's an XY, so you might think that this is a graph, but it's really showing a physical situation.
Yeah.
So it's not a graph in the traditional sense of a graph. So some things may be hard to interpret, whether it's a graph or an illustration, especially if it's specific to a particular field.
I think another thing can help the later is the figure title, because this one is really obvious. It's NWMR configuration. So yeah, it shows that it's not a graph.
Right.
And the second one is as well, it's like a C1, C2 as an XY graph.
Right.
But if you look at the figure title, it's not.
Okay.
Right. It's an example of the space partitioning. Yeah. And this one is these two figure in the research detail.
Okay.
Okay, we look at the testing divisions, or we have a lot of the graphics. Okay, in this is a figure 3, but if you look at here in figure 3, we have 6 graph here, yeah, and then in figure 4 we have 4 graph, and this one is quite special, the table 1, because this one is show the parameter used in the simulations. It's not the result at all.
Right.
Yeah. So.
And it's interesting because it has the like the parameter and then the setting, but it actually has 2 columns.
Yeah.
But it's basically a list that's broken into 2 columns just to save space.
Yes, right.
So it's not really a table in the traditional sense, but that's the only thing they can call it, because they don't have parameter list as a
yes,
as a designation.
Actually this one is a parameter list, but it just save the space as you just tell.
Right.
Yeah. So this one is not count as a non-numerical or numerical table as you have mentioned in the before.
Yeah, but if you had to call it something, you would probably call it non-numerical, because you're not comparing any numbers in it. It's just a list.
Yeah.
Of
it's like
values.
To state the conditions.
Right.
Yeah.
Exactly.
Okay, and the other one is also this one is illustration to show how to set up the experiments. And this one is a experiment results. This one as well, but they record and just pick up some snap of the video record here. So this one
again,
is
you have graphs and illustrations in the same figure. Right.
Yes, right.
Now we'll look at the graphics in our electrical engineering article.
So in this article, the graphics at the beginning in the introduction session, and it will be the first figure in relimetry, and it will be focused on the how to the model jet queen equivalent, just the standard, and then later on they will have the graph in their design, their research, like this.
Yeah, so this is very common in electrical engineering, that they have some sort of a diagram in the introduction that talks about the whole system.
Yeah, usually in the electrical engineering, they will have the big picture at the beginning to say what they are doing for their work.
Yeah, and so this does the same. It gives sort of the general picture before talking about the specifics of their research.
Yeah.
Okay. And then what else is interesting?
Another here. So some paper in electrical field, they also call this is a figure. Yeah, but this article, they didn't mention that. They just call this algorithm.
Right. So sometimes it refers to, as you can see in algorithm 1, and other times the algorithm will have a separate figure designation, because it's not a table, so it must be a figure. Those are the only 2 options. Algorithm is sort of a separate category, so sometimes it gets a separate designation and sometimes not.
Yeah.
Like here. Okay. What else?
And if we look at the table, so here is the condition, just little condition.
Okay.
It's not the normal table to comparison.
Right. So this is like Bong's table of parameters,
Yeah.
the settings that we're going to use. Okay.
And in here, we also have the table with the comparison, the two different methods.
Right. So this is the typical table that you would have in the testing division that shows the results of the comparison.
Yeah.
So now let's look at the tables. We have known that there's a graphical abstract, so we can get one graph and one illustration at the abstract division. And there's no tables or figures in the introduction method and discussion division. So all of the figures are in the result division. And because of the figure 6 that we got one graph and one illustration, so we got 0.5 and 0.5 each in the results and discussion division.
Of my mechanical engineering article in this table here, and note that number in the parentheses, it represents the number of figures and number outside. It represents graph and illustrations. And for example, in this column, in this row, there are 4 figures in the testing divisions, but in these 4 figures, they have 13 graphs and 2 illustrations. And right now, we want to look at the relationship between the table and figure and IPTC division in this case. As you can see, most of the figure and the tables, they belong to the testing divisions, but only a few, they belong to the process division and no table and figure in the introduction and conclusion divisions. And why this happened? The main reason is the researcher in this field, they prefer to describe the results in graph format. So that's the reasons why we have a lot of figure and tables in the testing divisions. And sometimes the researchers try to describe some research detail in the schematic or diagram. So we have a few illustrations in the process divisions. And introduction and conclusion divisions, the researcher can describe all things in words. So we have any figure or table in the introduction and conclusions.
This is the table summarize the graphics by division in electrical engineering article. And as you can see in the process division, we have total 8 figure and 1 table talk about the condition. And in the testing division, they have 2 tables and don't have any figure.
Okay, so let's try to summarize and compare the different articles that we've looked at. Chemical engineering was the only one that had a graphical abstract and therefore had graphics in the abstract itself. And that's relatively common in chemical engineering, but very rare in most other fields. Apart from that, all of the graphics were in the results and discussion division. Similarly, in the mechanical engineering article, we found that most of the illustrations, most of the graphs were in the testing division, although there were a couple in the process. And then in comparison, the electrical engineering article had a lot of illustrations in both the introduction and particularly the process division, showing how this was set up. And again, that's very common in engineering because it's hard to describe in words these new designs. And so this is a common pattern, but it's not true for all articles or all fields. And so again, you need to compare your own field and find out the pattern in your own field. Okay, so we've looked at the numbers of graphics in the different papers, but there's also a difference in the text and the way they're described. In yours, there's usually more description of in table such and such look at something. Why do you think that is?
Yes, because if there's a table or there's any graphs, because they include many data points, it shows a trend of property of the material. So we have to explain that the trend, that the comparison of each other, that different parameters, and so there will be a lot of explain or describe. So if there are no describe, then maybe the readers won't know that why they put the table or why they put the graphs here.
Right. There's tables and graphs are used for lots of different things. And so if you don't say what to look at, okay, it's a line, but what should I notice about the line?
Yes.
Whereas in some of the other, your illustrations, your schematics, someone knows what to look for, right? You look at a schematic.
Yeah. So someone will familiar with the schematics, so they will know what's the meaning.
Right. Yeah. So in each field there are special things that you have SEMs. You know how to look at an SEM, but they probably don't because they haven't seen them. So a lot of these graphics require field-specific knowledge and able to enable you to interpret and understand them. Yeah. And so you don't know how much detail you need to describe until you know your audience.
Yes.
If your audience is familiar with it, you don't need to describe as much. So you always need to consider your audience in your writing.
Yes.
Yeah. Okay, good. Well, I think that's probably enough for graphics, and then next week we'll finish up. If your research uses statistics, it's important to pay attention to that, to read section 8.6 in the text and other places that you can find listed under statistics or statistical in the index. These are some terms: statistical standard deviation, confidence interval, others that will indicate statistics. They're not very common in engineering, so I'm not going to talk about them here. But again, if it does apply to your article, please pay careful attention to those. Now, your assignment. Again, you need to determine where various types of support from current research are found in your own article, where the breaks occur between past and present, what types of equations, details, data are used, and where they occur. And then make a table to summarize where the different types of graphics are found. You'll find this helpful when you do your own writing, so you have an idea of how many graphics you're going to need and where they should be placed in the article.